Hey, fifth graders, here we are. We are in what lesson are we getting into?
28.
Lesson 28. You lucky ducks are going to be missed so much over the next 2 days. You don't have school. Mrs. Herseth and I have the pleasure of meeting with your parents and celebrating all of your amazing successes over trimester 1. So it is your responsibility at some point during your days off to watch this video. This is going to be for lesson 28. We have lesson 28 and lesson 29. And then what happens after that?
Celebration of learning.
Yes! Yes, we're going to celebrate our learning with our end of module 2 assessment. I do have some very special guests in the room today who are going to share our secret word with you. What is our secret word, special guests?
Fluffy unicorns.
Beautiful. So our secret word again is?
Pink fluffy unicorns.
Terrific. There are actually going to be 2 secret words. That's our first secret word. Stay tuned for our next. Enjoy the lesson and keep up the great work. Hey, kiddos. Missing you. You're probably missing me a ton too. Mrs. Herseth and I are recording from her classroom today, and we have just had the best time meeting with your parents. It's been an awesome couple of days, and just an extreme pleasure celebrating your guys' victories and growth with your parents. So we are going to get into lesson 28. I'm going to do a doozy of a problem here, and then when I see you guys tomorrow in class, we are going to continue working on like some pretty intense multi-step word problems that are going to synthesize all of the learning that we've been doing in module 2. So let's take a look at this one. Jim Nassim is building a treehouse for his 2 daughters. Aw, what a guy. He cuts 12 pieces of wood from a board that is 128 inches long. So as I'm reading this, try to picture this happening in your head. He cuts 5 pieces that measure 15.75 inches each, and 7 pieces evenly cut from what is left. Jim calculates that due to the width of his cutting blade, he will lose a total of 2 inches of wood after making all of the cuts. What is the length of each of the 7 pieces? Wow, Mrs. Herseth, that's quite a problem, huh?
Wow.
Whoa, my brain hurts a little bit. Okay, so let's just break this down. We're going to draw a visual so that we can organize all of that information that was just thrown at us. And we're just going to make it as organized and orderly as possible. So here goes nothing. So we're working from one wood board. Imagine that this is a really straight rectangle because that's my intention. I know it looks a little wobbly. So this is one wood board. Let's go back to the problem. This one wood board is how long, Miles? How long is this one wood board? It is originally 128 inches long. Thank you, Miles. So we're going to label it as such. This whole wood board is 128 inches long. That's what we start off with. That's what I bought at Home Depot. Or actually Jim. This is what Jim bought at Home Depot. And then he's going to cut it up in a few different ways so that he can make that tree house for his daughters. So first he's going, the problem tells us that this wood board is going to be cut into 12 pieces. So I'm going to go ahead and cut this board into 12 pieces. We have 1, 2, 3, 4, 5. Keep in mind these are not proportional. 6, 7, 8, 9. Good counting, Gabby. 10, 11. Oh, yeah, here comes the not proportional 12. So here we have 12 pieces. And now let's think about what he does with these 12 pieces. So he cuts 5 pieces that measure 15.75 inches each. So 1, 2, 3, 4, 5 pieces. Let's label these. 5 pieces are cut at 15.75 inches each. So that one's cut to a length of 15.75. This one, I'm going to label all of these. Typically we wouldn't label them all, but this is a pretty complicated problem, so I just want this to be as visually organized as possible. So we have, again, we have 1, 2, 3, 4, 5 pieces that are cut at 15.75 inches each. Okay, and then we have 1, 2, 3, 4, 5, 6, 7. Oh dear, did I? 1, 2, 3, 4, 5, 6, 7. Sorry guys, this is not here. The scribble, you don't see that. I got too excited with my cuts. Pretend this isn't here. I know it's hard to pretend that because it's a scribbly mess. We should have a group of 5 and a group of 7. 1, 2, 3, 4, 5, 6, 7. Our original board is cut into 12 pieces. Pretend we never saw that. So these 7 pieces are going to be cut into equal parts with whatever we have left. Now here's where our calculations come in. If this entire board is 128 inches, what is this section? Or how do we figure out what this section is? Well, we have 5 pieces of 15.75, or we have 5, this button. So we have 15.75 times 5 copies. Let's figure out what the length of this section is. We're going to make 5 copies of 15.75. Let's go through this. 5 times 5, thank you Chloe, is 25. Carry our 2. 7 times 5 is 35 plus 2 is 37. Carry our 3. 5 times 5 is 25 plus 3 is 5 times 5 is 25 plus 3 is 28. 5 times 1 is 5 plus 2 is 7. 5 copies of 15.75 is 78.75. So this section here measures 78.75 inches. So if this whole board is 128 inches and this part, this section here is 78.75 inches, how do we decide how long this section is? Well, we're going to take 128 and we're going to subtract 78.75. Again, this entire board is 128 inches. We know that this chunk over here is 78.75 inches. We need to find out this missing chunk, and we can do that by just subtracting 78.75 from 128. And you guys are excellent at that, so let's get to it. So we can't take a 5 from 0, so we're going to have to do some regrouping over here. It's going to start with our 8. Okay, and now we need to borrow from our tenths to make 10 hundredths. So we're just going to do very straightforward subtraction here. 10 minus 5 is 5. Thank you, Eric. 9 minus 7 is 2. We're just going to bring that decimal point straight down. 7 minus 8, can't do it. I need more. Regroup. 17 minus 8, can do it, is 9. 7 from 1, can't do it. We need to regroup again. Uh, 11 minus 7 is 4. And we're good. This section here is 49.25 inches long. Okay. Now let's go back to the problem. We read, so he cuts 5 pieces that measure 15.75 inches each. Great, we handled that. And 7 pieces evenly cut from what is left from that. So that's what we're doing over here. Jim calculates, so here's just taking it to a whole nother level. Jim calculates that due to the width of his cutting blade, he will lose a total of 2 inches of wood after making all of the cuts. Okay, so this chunk is not going to be 49.25. He's going to lose 2 inches. So let's go ahead and lose those 2 inches right now. 49.25 minus 2 is 47.25. He's going to lose 2 inches because of some blade complication, I suppose. So now we have 47.25 stretched evenly across how many pieces? Stretched evenly across 7 pieces. Now we need to figure out how long is each piece. How are we going to figure out how many 7s, or how long each of these 7 pieces is? I think a lot of you are already realizing that we're going to divide. We're going to divide 47.25 across 7 equal pieces. So you guys have been working so hard at this. Let's go ahead and bring our decimal up. Let's think about how many 7s live in 47. I know 7 times 7 is 49, so that would be too much. What about 7 times 6? 42. Yep, I think that's going to work. 6 times 7, 42. You guys are great at knowing your math facts quickly. We need to figure out the difference between these two numbers, but let's ask Mrs. Herseth for our second secret word.
Second secret word is port key. Port key. One word, port key.
I don't know what that is, but I'm sure you guys do. Thank you, Mrs. Herseth. The difference between 47 and 42 is 5. We're going to do a quick check and we're going to think about, is 5 less than 7? The answer is yes. So now we can safely bring down that 2. And now we need to think about, how many 7s live inside 52? How many 7s live inside 52? We're just going to use our multiples of 7 to decipher that. I know 7 times 6 is 42. 7 times 7 is 49, and that's pretty close to 52. So that is what we're going to use in our tenths, the tenths part of our quotient. We are using a 7, not a 9, Mrs. Calmers. Okay, and we're almost there, you guys. 7 times 7 is 49. I'm running out of space. What is the difference between 52 and 49, Ali? Ali is saying it's 3. I'm out of space here, you guys. I usually would put that 3 underneath both of our numbers. I'm just asking you to be flexible. We're going to bring down our 5. And now we're looking at how many 7s live inside 35. I think a lot of you are really excited because you're realizing that this is almost over. There's 5 7s that live inside 35. 5 times 7 is 35. I'm going to try to sneak this in down here. And the difference between 35 and 35 is 0. So our final answer, my word, after a lot of hard work, is 6.75 inches. Each of the 7 pieces is going to be 6.75 inches. Wow, that's a lot of work. Great job on that one, you guys. I look forward to seeing you tomorrow and working hard. It's going to be a great Friday. Keep up the great work.